You might be a little surprised to know that the midpoint rule is actually a better approximation than the trapezoidal rule. And the trapezoidal rule instinctively seems so reasonable if our delta x is really small. But suppose it's not, or even if it is, here's what's going on with the midpoint rule. That's kind of interesting. So we're going to so look at the diagram I have. So we have this function f of x. We're going to use the midpoint rule to approximate this area between a and b. And I'm going to take the midpoint of a and b. And what you know I'm doing is creating a triangle that supposedly is going to approximate that area. It certainly doesn't look that way. But here's what I'm going to do. What we're doing when we're doing the midpoint rule is, so this bottom rectangle that you can see, what I'm going to do is I'm going to draw a tangent line. And what you will notice is that what I've actually created are two congruent triangles, right? This is a midpoint, so those two legs are congruent. We have right angles, and our vertical angles are congruent. So by angle, side, angle, I have two congruent triangles. So what I have created is this trapezoid. I'm going to just color it in a little bit. So here's this trapezoid. And this trapezoid actually has the same area as the rectangle that I created for the midpoint rule. So notice that when we create a midpoint, when we're using the midpoint rule and we create a rectangle, what we are also creating is a trapezoid that has a side that is tangent to the curve. So two things to notice. Number one, this trapezoid is an under approximation because our function is concave up. And the other thing to notice is that if I were actually going to do the trapezoid rule, so if I was going to create, let's say, that, right? So here's my trapezoid from the trapezoid rule. That, in fact, would be an over approximation. But it certainly looks as though, and is often the case, that the midpoint approximation, so the lower trapezoid, is sort of a better fit than the upper trapezoid. So that's why the midpoint approximation kind of works. But it's also good to know that we're really creating a trapezoid when we're using a midpoint approximation, and the non-parallel side is tangent to our curve. So if our curve is, let's say, concave down, then in doing the midpoint rule, what I'm actually doing is creating that trapezoid, which is going to be an over approximation.